Bachcho, let's read this question. So the question says that discuss the trend of the following. So there is two questions. First is thermal stability of carbonate of group 2 element, and the second question is the solubility and the nature of oxides of group 2 elements. So generally you have to discuss on two topics. First topic is thermal stability of carbonate and second topic is solubility and nature of oxide. So let's solve this question. So first we'll see the first question, that is group 2 elements. So what are those group 2 elements? So B, Mg. So these are the alkaline earth metal, or we can say it as group 2 elements. Group 2 elements, and they all can form carbonates. All alkaline earth metal can form carbonates. And if you see, then if you go from top to bottom, then its electropositive character increases. Going down the group, as electropositive character increases, that means ionic character is also increases down the group. Ionic character also increases. As ionic character increases, so thermal stability of carbonate also increases. Electropositive character increases, that means ionic character also increases. That means thermal ability also increases. Thermal stability. So thermal stability also increases going down the group. So now the metals, like if we'll take the group 2 metal like this and we treated with MCO3, that is carbonate, and it forms MCO3. So this is the general formula of carbonate of or alkaline metal carbonate, MCO3. So this is the justification why thermals, or the discussion that thermal stability of carbonate of group 2 element. Generally all group 2 elements form carbonates, and the elements are beryllium, magnesium, calcium, strontium, barium. So these are the elements. Now when we move from low to bottom, then electropositive character increases as size increases. So for that reason ionic character also increases. As ionic character increases, thermal stability also increases. So going down the group, thermal stability increases of the carbonate group. So if you see the carbonate like BeCO3, then comes MgCO3, then comes CaCO3, then SrCO3. So this is the order of carbonate group. So if electropositive character increases, ionic character increases, thermal stability increases down the group. That means the SrCO3, the thermal stability of SrCO3 is more as compared to CaCO3, MgCO3 and BeCO3. So this is the answer of this first question. Now we'll proceed to second question. So second question is solubility of the nature of oxide of group 2 element. So generally you have to tell the solubility and nature of oxide. So we'll write beryllium, then magnesium, then calcium, then strontium, then barium. So these are the group 2 elements. Now they form oxides like BeO, MgO, CO. So when it reacts with oxide like M plus O, and it gives MO, MgO, CaO, SrO, BrO. And if we write the nature of the oxides, so it is its general formula of oxides. And if we write the nature of oxide, then except BeO, which is we can call it as amphoteric, which is amphoteric. Except BO, all are basic. All oxides are basic. So except BO, which is amphoteric because of its small size, and all oxides are basic. Weak base may be strong base, but all are basic. So now we'll write the solubility. We'll see the solubility. So when we going down the group, or when we go from top to bottom, then lattice energy size increases. Size increases, that means lattice energy decreases. So lattice energy decreases, that means melting point decreases. So melting point decreases, that means thermal stability decreases. So thermal stability decreases, that means water solubility increases. So we'll write the structures like BeO whole OH2, Mg OH whole 2, CaOH whole 2, SrOH whole 2. So this is the oxides when when it reacts with water. So when we go from left to right, or going down a group, or from top to bottom, then down the group size increases. So size increases, that means size increases. So size increases, that means lattice energy decreases. Lattice energy, as size increases, so lattice energy decreases. Lattice energy decreases, that means melting point. Melting point decreases, as lattice energy decreases, so melting point decreases. Melting point decreases, that means water's thermal stability decreases. Thermal stability decreases. Thermal stability decreases and water solubility increases. Water solubility increases. So when you're going down the group in hydroxides, like when size increases, lattice energy decreases. So when lattice energy decreases, that means melting point decreases. So melting point decreases, that means thermal stability decreases. As thermal stability decreases, water solubility increases, because they can easily react with, easily accepts the electrons of water, because water has lone pair, so it can easily accept. So for this reason, when size increases, or from going down the group, or from top to bottom, water solubility increases. So the solubility and nature of oxide. Now we'll know that the solubility and the nature of oxide. So hope you will understand this question.